Okay, so try to remember with your partner what those ratios are and write them on the triangle. Because if you these are key to being able to fill out your unit circle. Okay. So if you don't remember, I'm gonna give it to you in a minute. Are y'all just watching the camera?
Yeah.
Oh, is it like squared?
Is it like squared?
No, for 36/9 it's like squared cubed times 2.
Yes.
There is a times 2.
It's across the hypotenuse times 2.
What's the hypotenuse?
The one across the box.
Brody. Hi, Emma. Go that way.
Hi,
or you're going to walk right in front of the video camera. Go around. Come back up this way. All right. You can just draw it on the side, or you can write it on the triangles that I wrote underneath the box that we're working in right now. Okay? Okay, so I heard Fisher say in the 30/60 that the hypotenuse is times 2. Okay, so this is a 2 here. All right, do you remember what the other sides are?
The 90 is cubed.
The side across from the 60 is the radical 2.
The side across from the 60 is square root 3. What's this one?
Radical 2.
Nope, radical 2 is in this one.
Isn't it just a number?
N or just 1, okay? So the ratio when we write it is 1 square root 3, 2. That's the short leg, the longer leg, and the hypotenuse. Okay? Does that sound a little bit familiar?
Yeah.
Okay. So what about the 45, 45, 90?
Radical 2.
On the what?
On
the bottom.
Adjacent.
The adjacent to the hypotenuse.
No. The radical 2 is the hypotenuse.
Oh, yeah.
This is 1, 1 square root 2. Okay? Because those angles are the same, the sides opposite them have to be the same.
What
Okay?
switches it up? Isn't there something that like messes it all up?
Dude, we did something with the.
Now, I mean, you can flip this triangle over and put the 60 down here, but the ratios still remain the same. If you think of it later, tell me and we'll talk about it. But this is the leg and the hypotenuse here. The two legs of the 45 are the same because they're across from angles that measure the same. Okay? So 1, 1 square root 2. Okay? So now, let's talk about sine, cosine, and tangent. What's sine? What over what? Opposite over hypotenuse. Okay, so number 1, I'm going to do 1 with you, and then you're going to do 2, 3, and 4, and we're going to check them fast, okay? All right, number 1, sine 60. Put your finger on the 60 and do the opposite over the hypotenuse, which would be what? Root 3 over 2. Okay, you answer the rest of them. And do not leave radicals in the denominator. Because I believe that the cosine 1 will leave a radical in the denominator. You need to fix it. At all? When I stand like this? Now it's trying to find me and I'm standing behind it. Can you see what I wrote now? Okay. I just want to be able to point today, and I can't if I do the normal way that I record, which is just sound. You can't see where I point. All right, so did we remember what tangent is? Tangent's what over what? Opposite over adjacent. Opposite over adjacent. So tangent 45 is going to be what? 1. It's 1 over 1, which is 1. Okay? All right, cosine 45. It's 1 over square root 2, but I'm not leaving that like that. Rationalize that. You should be able to do that in your head. What is that?
Radical 2 over 2.
Square root 2 over 2. Yes? Okay. Cosine 60. 1/2. Everybody okay with that? Anybody have any questions about that? Okay. Now we're going to transition to doing some stuff on the unit circle, okay? Here's the deal. A unit means 1, right? So if I draw the unit circle, may I borrow yours, Ruth? If I draw the unit circle, which is what this is, the radius is 1, okay? So every triangle that I put on the unit circle, the hypotenuse is 1. So you see how our two hypotenuses, not sure if that's the right word, are not 1. Okay? So we've got to refigure a little bit our triangles in order to make them 1. Okay? So this is the 30, 60, 90 that we just had on there. Okay? What we originally had was 1 square root 3, 2. Right?
But we got a 1.
Now this is a 1. So what do you do to this 2 to make it a 1? Divide by 2. So guess what you're going to do to all the other sides? Divide by 2. So this one is now square root 3 over 2. And this is on the unit circle. And this one, oops, backwards.
No, the wrong one.
Yes. That one's 1/2. 1/2. And this one is square root 3 over 2. Everybody okay? Okay. Now do the other one. If this is 60 right here, so this here's the 30. So what's going to go on this side now? What's opposite the 30?
2. I mean 1.
1. So now it is 1/2. What's opposite the 60? Square root 3 over 2. Okay? Is everybody okay with that? Okay. Now, this one's a little bit tricky. This one's a little bit tricky. Okay? Because now this side, what were our original ratios?
Root 2, 1 and 1.
Root 2 here, 1 and 1. Those were my original ones, right? Now I'm saying this root 2 has now become a 1. That's not easy to change, right? So we've got to do a little ratio here to set those up. Now once I figure out what one side is, it's automatically the other one, right? Yeah. So ratio 1 over square root 2 is equal to x over 1. You see what I did? This side compared to this side is this side compared to this side, whatever we want it to. I set up a ratio, a proportion. Okay? So when I cross multiply, I get 1 equals square root 2 of x. Now what? What do I do to solve for x? Divide by square root 2 on both sides. So what's x going to be? Fix this. Square root 2 over 2. Okay? Okay? Now, grab your unit circle, because now we're going to fill it out.
Oh my God.
How many of y'all remember this really well from Algebra 2? Nobody. Yay. Okay. Yes, you did. Okay. Here's what I would like for you to do. Do you see how my unit circle has some angle measures in radians and some in degrees? Okay. Go ahead and write these in on yours. Do you see how each one of your lines has a radians line and a degrees line? Does everybody see that on your unit circle?
Yes.
Okay. So go ahead and fill in this. And I also want you to fill in the corresponding one. Okay, so here's what I mean by that. What is 30 in terms of radians? 30 degrees. What do you do? Multiply it by pi over
2.
180. which reduces to pi over 6. So each one of these angles has a corresponding degree in radians. Yeah, 30 degrees is pi over 6.
How do you get that?
30 times pi over 180. That's the conversion. So 30 divided by 180 is 1 over 6 pi. Okay? All right. Now, so some of y'all may want to fill in the degrees all the way around first and then do the radians. But I put the radians, some of the radians and some of the degrees up here. Okay?
You can memorize this.
No, I'm going to show you a trick here in a minute. I'm going to get this to stay up here so that I can walk around. I'm going to pull it over to this side. Yeah. Oh. Perfect. You just mark on the screen. Now, you may want to be writing this in pen or in pencil just in case you mess something up.
No mess ups right here, man.
Now, I want you to really think about, as you're moving around the unit circle, the patterns that are involved here. Okay?
You go 3, 4, 6, 6, 4, 3.
So, did y'all figure out what the radians is for 45?
No.
What's the radians for 45?
What's 45
Pi over 4.
Pi over 4. Good.
Oh, I bet you the next one's gonna be pi over 3.
Pi over 4. And then pi over 3.
Yeah.
And then what's the one up on the y-axis? Pi over 2. Okay, now we know this one is pi. What's the corresponding degrees? 180. Okay. We also know this one's 270. What's the corresponding radians?
3 pi over 2.
3 pi over 2. Right?
Yeah.
Okay.
Yeah.
Now, here's what I want you to think about. Okay? Because some of y'all are sitting there doing the conversions for every single one of these. Okay? How far do you move to get from here to the first dot? 30 degrees, right? So guess how far you move from here to here? 30 degrees. So what's this degree mark right here? 120. Does that make sense how I figured that out?
Yeah.
How far do you move from here to here? No, from here to here. 30. So move back 30 this way. That makes this one what? 150. Does that make sense what I'm saying? Okay.
135.
What's the middle one's 135. Okay. What's this? What's 7 pi over 6 going to be?
210.
210. What's the next one? 225. And then what's the last one?
240.
240.
Is that right?
Everybody okay?
I'm just guessing.
Is everybody okay? Okay. Now let's talk about the radians over there in that one. So we're not converting every single one of these. Okay? This is also 2 pi, right?
Yeah.
Going all the way around is 2 pi. Okay? When you go from here to here, it's pi over 6, right? So guess what happens if you go from here to here?
6 pi.
You move pi over 6, right? Okay, so 2 pi is 12 pi over 6, right? 12 divided by 6 is 2. What happens if you subtract a pi over 6 from it?
6.
How many? 11 pi.
Oh.
11 pi over 6.
How'd you get that?
This is 12 pi over 6, this one here. And I subtracted 1 pi over 6. Yeah, not 2, 1. Holy cow. Okay. All right.
You're tripping.
I know. It's because that thing is triggering it up there. Okay. What about this one?
Which one?
This one here. Did some of y'all figure it out radians wise?
It's
7
gotta
pi
be
over
like.
It's 7 pi over 4.
Alright, how'd you figure it out?
Okay. So do 2 pi in terms of 4. It would be 8 pi over 4, right?
Yeah.
Subtract 1 pi over 4.
Uh-huh.
Okay. Now this one's pi over 3, right?
Yeah.
This would be 6 pi over 3.
5 pi.
So it's 5 pi over 3. Okay? Everybody okay with that? Okay.
Sure.
Now, I promise you, is any of this looking familiar from Algebra 2? Okay. The more that you work with the unit circle, the quicker you'll be figuring them out. Okay? You'll just remember how they correspond to each other. Okay. Next thing I want to look at is these coordinate points that go on each side. Okay? What are the coordinates right here?
0, 0.
No, this is 0, 0, Brody.
0,
What's
1.
not 0, 1? 1, 0. Yeah, 1, 0.
That's what I meant.
1, 0. What's this one?
0, 1.
0, 1.
Yeah.
What's this one?
0, -1.
Negative 1, 0. And what's this one?
0, -1.
0, negative 1. Everybody okay with that? That's just regular coordinates on the coordinate plane. Okay. Now, I'm going to draw a triangle on here for you to see. Okay?
I don't do well with time. I really don't. I don't know why you're laughing.
Okay. This 30 means that the angle right here is 30. That's what that means. Look at the triangles we just figured out.
Yeah.
The one that puts the 30 down here.
Mm-hmm.
What is this length of it, of that triangle we just figured out? What is it?
Root 3.
Root 3 over what? Because we're on the unit circle. This is a 1, root 3 over 2. And what's this one?
1/2.
1/2. Okay, you don't need to draw this triangle in because it's going to confuse you in just a minute.
3 over 2. 1/2.
So, what are the coordinates right here? Root 3 over 2,
1/2.
1/2. Guess what the coordinates are for 5 pi over 6?
Root 3 over 2 over 1/2.
Root 3, well, it's not root 3 over 2 because where did we go for the coordinates for the
Negative
x?
Root 3 over 2.
They're negative. So negative root 3 over 2, comma, positive 1/2. Because when I move to quadrant 2, x has become what? Negative. What happens when I move to 3? Everything's negative. So we have negative square root 3 over 2, negative 1/2. What about over here? What about this over 6?
Positive negative 1.
Positive square root 3 over 2, negative 1/2. Does that make sense?
Yeah.
Okay. All right. What are the coordinates of pi over 4? What are the two legs of the pi over 4 that we just...
45.
That's the angles. What are the legs? What are the lengths of the legs? Not 1 and 1 because we've now moved to the unit circle. What's the new ones?
Oh, root 2 over 2.
Root 2 over 2,
Root 2 over 2.
root 2 over 2. All right, go all the way around your circle and fill all the over 4s in because they're the same. Once you know this one, you know all the root 4s. Okay. Now the last one. How does the last one, how does the pi over 3 coordinates compare to this one?
They're gonna be 1/2.
Yes, it's just the opposite. So it's 1/2, comma, square root 3 over 2. All right, fill those in all the way around. Uh-huh. It's just the opposite of the 30. Okay? Do y'all remember this from Algebra 2?
Yeah.
Yeah? Some of us are looking at me disdainfully. Okay. All right. I would like for you to, here's the notes that I want us to make about this before we go on, okay? Is I want us to talk about what sine and cosine are on the unit circle and tangent, okay? So sine of any angle on the unit circle, cosine of any angle on the unit circle, tangent of any angle on the unit circle. Okay? All right, so I'm going to use my blue triangle that I drew here. How would I find the sine of this? What would it be? What would be the sine of 30 right here?
Sine 30 is
Opposite over hypotenuse, right? So 1/2 over 1, or just 1/2, right? Which is which coordinate? The y coordinate. Okay?
And then cosine equals.
What are you trying to figure out?
The sine theta, you told me that sine was 1/2 over 1, right?
Yeah.
Or just 1/2, because they're all going to be over 1. The hypotenuse is 1 for every triangle, okay? So what coordinate is that when I look at my coordinates right here?
Wow.
It's the y. So so if I were to ask you, hey, what's sine of 300? Guess what it is? Negative square root 3 over 2. It's the y coordinate. Okay? What's cosine? Be logical. What's cosine?
X.
X. I finally figured out what this is. It's my ponytail. It's hitting the board and making all these stray marks. Okay. Now, what's tangent?
X.
Think about it right here. What's tangent of 30? This over this, which is, this is not x. What's this? It's y over x. Yeah. Okay? All right. I want you to try to answer example 1, A, B, C, D. Now that we've got the unit circle filled out, these go quick. And I'm going to show you my trick here in a minute.
Big louder. ACDs. It was Stacey D's idea.
No, it was not.
Yes, it was.
I'm glad I'm going to be absent that day. I probably shouldn't have said that on video.
You want to tell me again?
All right, how we doing? I want to walk around, so. I like it with you.
Travis, anyhow. What do I do?
Oh, yeah. So all of us are stalling out on C with how to fix it. Okay. All right. What's A? What's A? Cosine 225. What do we all get?
Radicals, negative radicals,
Negative square root 2 over 2. Everybody okay with that? What about sine 315? Negative square root 2 over 2. All right, tangent 5 pi over 6. So I saw a lot of this. Negative, it's negative down here, right?
Yes.
Yeah, okay. We don't leave fractions in fractions, and this is like 2 fractions in a fraction, okay? How do you fix that?
Multiply by the reciprocal.
Yeah, exactly. So 1/2 times negative 2 over square root 3. What happens to the 2's?
Cancel.
They cancel. And I get negative 1 over square root 3, which I know how to fix.
Negative root 3 over 3.
Negative root 3 over 3.
God, I'm on fire today.
Okay? Are we okay with that now that we see it? We just didn't remember to do that. Okay, what's a D?
It's 1/2.
You just don't like to? Negative 1/2. Okay. Now, the next little chart I put in your notes is a chart about where stuff is positive and negative. I will be honest with you, I do not memorize this chart. Okay? I think about X and Y are both positive here, so everything's positive. Okay? Over here, the x's become negative, so cosine becomes negative and tangent because they both have an x in it. Okay? And then you can go all the way around the circle that way. Ms. Porter teaches an acronym. All students take calculus. That's what she uses. Okay? This means everything's positive, sine is positive, tangent is positive, cosine is positive. So if you want to think about it that way, you can. I don't memorize any of that stuff because I use the little trick I'm getting ready to show y'all.
Is that true?
Okay? What? No, that's just an acronym that people use to describe it. Okay? All right. Did I skip? No. Yeah. Is it on the back? This one's not on there?
No.
No? What about this one? What in the world?
No, that one.
Oh, I just condensed them all. This is 330, which is on the bottom one, right? Isn't 330 your first one? That's your A, and then 270? Okay, yeah, so we're good. All right, use a reference angle to find the exact values of sine, cosine, tangent. Okay. Y'all remember reference angles from yesterday?
No.
What is the definition of a reference angle?
The angle that
The whole slice. The one to get you to
The one that gets you to the closest x-axis. Yes? Okay. All right. Sector is the piece of pizza. All right. How far do I have to move if I'm at 330 to get to the closest x-axis? 30 degrees. Okay. So my reference angle is 30 degrees. Okay? Now, here's why I don't worry about negatives and positives. I'll show you why in just a minute. Okay. Now, I taught this trick last year, and this is partially why I wanted to videotape. So I'm going to show you this trick. But let me move over here to the whiteboard so I don't write all over that board. Okay. So, visualize. And you can use this trick all the time. This is the quadrant 1 of your unit circle. So my top finger here is the y-axis, and my thumb is the x-axis.
I remember.
Yeah? Do you remember it now that I'm showing you? Okay. So the angles 30, 45, 60. Or did y'all notice the pattern? This one's pi over 6. This one's pi over 4. That one's pi over 3. Okay? All right. Watch. Prepare to be amazed. Okay? To figure out the coordinates at the 30, I fold my 30 finger down. Okay? Do you see I have 3 fingers up here? This one is square root of 3 over 2. They're all over 2's. Okay? You see I have 1 finger down here? This one is 1/2. Look at yours. Am I right? All right, watch this. Watch. Fold down the 45.
Square root 2 over 2.
What's this? Square root 2 over 2.
And then 1.
Square root, nope, look, how many fingers?
Square root 2.
Square root 2 over 2. Does it match with yours? Watch this. Fold down your 60. What's the coordinates? What's how many fingers?
1/2.
1/2,
Square root
comma,
2.
square root 3 over 2. See why I don't memorize the unit circle? Okay, so apply that to the problem that we're working on right now. Okay? Reference angle is 30. Fold your 30 finger down. What are my coordinates at 30 without looking at your unit circle?
Root 3 over 2.
Root 3 over 2, 1/2. What quadrant is this in?
Root 3 over 2 negative.
No, 330. What quadrant?
Root 3 over 2 negative.
4. Which one of these is negative if we're in 4?
1/2.
The negative 1/2. Okay, now answer your question. What's sine, cosine, and tangent?
Sine is
Negative
negative 1/2.
1/2.
Cosine is root 3.
Negative 1/2. Cosine,
Root 3 over 2.
root 3 over 2.
Tan.
Tangent.
That's the
It's this over this. Now we have already reduced that one time.
root
We've
2 over
already
2.
done negative 1/2 divided by root 3 over 2.
Root 3 over 3.
Negative root 3 over 3. Once you've done it one time, you'll see the pattern. Okay? All right, I want to do 4 with you, and then I want you to try C and D. Okay, the ones in radians. Okay? All right, 270. 270 is 90. Where is 270, though? Where is it? Okay? So, if we want to talk about a reference angle, it would be 90. What are the coordinates at 90?
1, 0, 1.
0, 1, but 270 is going to be 0,
Negative 1.
negative 1. All right, what's the sign?
Sine is negative 1.
Sign, remember, sine is the y coordinate.
Sine is negative 1.
So sine is negative 1. Cosine is
Zilch.
0. Tangent is,
Negative 1.
oh, time out. Neither one of y'all are right.
Undefined.
It's undefined. Yeah.
Okay, B.
It's undefined. Because it is negative 1 divided by 0. Yes? Everybody okay? Okay. I want you to try the 2 with the radians.
Oh.
Are we dying? I know
Well,
y'all are
I
dying
mean, you
today.
should just know that 11 pi over 6 is
So what's the reference angle for 11 pi over 6?
30.
Pi over 6, or 30. What are the coordinates there?
We just did this one. This is the same one as the first one.
It is the same one.
Okay. Square root 3 over 2, negative 1/2, and you go to 10. All right, try D as well. I'm going to take this thing off so it won't follow me.
3. You don't have any negative pi.
Oh, Zane, explain Brody where negative pi over 3 is. What do you do if you go or Joe or Corbin or anybody around Brody, explain to him what to do for negative
Well,
pi
I know
over 3.
pi over 3 is 60, so negative pi over 3's got to be like, what, 30? 300?
So for negative, you just go this way. Yes.
These things are
All right, there's your coordinates for the negative pi over 3. Because where's negative pi over 3? What quadrant? 4.
What's tangent for this one? It would be 2 root 3.
No, but you did. Yeah. you do that? Because we don't write answers 2 over 2.
Oh.
They cancel out. All right. Okay. Are we doing okay? Or are we dying a little? We're dying a little? Okay. I know it's heavy stuff, but the lesson on Monday is really easy, so I actually flip-flopped them so that I could teach you this and be physically in the room, then teach this on Monday when I wasn't going to be here. So,
You're not gonna be here?
no, you missed that whole discussion too yesterday.
We had a certain item Monday and Tuesday.
Let's go!
Thanks, Birdie. That makes me feel real good.
No, I'm saying I love Niger. I love you. I love Niger.
All right. So here's what I want you to notice. Here's what I want you to notice. All the over 3s, all the over 3s, 5 pi over 3, 7 pi over 3, negative 20 pi over 3 are going to have these answers. Okay? It's just going to depend on which ones are negative or positive depending on the quadrant. But these numbers stay the same. Okay? All the pi over 6, which is this one, and this one here, all the pi over 6s are going to have these answers. Only thing that's going to change is if they're negative or positive, depending on the quadrant that it's located in. Okay? That's why you don't have to memorize the unit circle. If you know quadrant 1 and you know the coordinates here, you can apply that to any one on the circle. Okay? All right, so here's what I want you to do. Flip your paper over, flip your unit circle over, and turn the page. I want you to answer these without looking at it.
Oh, what?
What?
Can we put it drawing?
Why would you draw it? Use your hand.
I don't know how to
I don't
do this
understand the
version.
damn thing.
Oh, man. You want me to do it again? You want me to do one with you?
I
Okay.
need help for the radicals.
Okay.
So like, you give me FaceTime, I'll talk to you.
All right. Hand trick.
Another hand trick.
Fisher said he didn't understand the hand trick, so I'm going to do it again. Okay. Sign 30. Which one of my fingers is the 30? This one right here. Fold it down. So the coordinates at 30 are square root 3 over 2, 1 half. Which one of those is sign?
1 half.
1 half.
I don't
Write
need
it down.
this. I need the number 3.
Okay? Now, look at number 3. It's an over 6, right?
Yeah.
Which one of my fingers represents the over 6?
Third one.
No, this is over 3. Remember, this is 0, 30, 45, 60, 90.
First one,
30
30.
is pi over 6, right? So same thing. All the over 6s, fold that one down. Okay? Which one is cosine? Square root 3 over 2 or 1 half? Square root 3 over 2. What quadrant is this in?
Second.
Second quadrant. So our x is negative or positive? Negative. So it's negative square root 3 over 2. You see how I did that without having to pull that circle out? Okay? All right, I'm going to take this off. I'm going to walk around. If you want me to come do the hand trick with you at your desk in front of you, I will do that. Try to answer the rest of them. You can do what Molly is doing over here, and she's drawing it on her desk so that she can reference it. Okay?
So if it's in the third dimension, like
So, now what's the reference angle here? How far to move? 60, so hold your 60 finger down. That's not 60 finger, that's 60. So which one of these is cosine? 1 half or the square root 3 over 2? 1 half. And now you're in quadrant 4. Is x positive or negative? Positive. Let me show you. Okay, which one are you doing? Cosine 45? Okay, so fold the finger down. So, square root 2 over 2, square root 2 over 2. That's your coordinates, okay? Cosine is x or y. X. So, square root 2 over 2. Write that down. What quadrant is 45 in? first one, everything's positive, so just say, don't do anything to it. However, for them.
I'm very good with the tangents.
So it's y over x, so square root 2 over 2 over square root 2 over 2, which is just what? It's, well, all of these hypotenuses on the circle are one, okay? So if we draw in a triangle right here, and we do the angle opposite over hypotenuse, then it's just the opposite from every unit over one. And the opposite is this up or down. Why that? And then this one. So here, for cosine, it's the adjacent, which is this length right here, over the hypotenuse, but the hypotenuse is 1. So it's just this length right here, which is your x coordinate. Alright, I'm walking around. Y'all know cotangent? Y'all remember cotangent?
No.
Is that like your bell that you're ringing something? Well, what's this one? Where's pi over 4? Which one? Which finger is pi over 4? Which one?
It would just be x over y.
Okay, what is this?
So, fine. So, which finger is on 6? Which finger is on 6?
I thought that was wrong.
33 by 60, pi over 6, pi over 6, pi over 6. Okay, tangent is normally y over x, right? Cotangent is yes, it's supposed to be cotangent.
See, all you people trying to tell me you're supposed to be cosine, it's cotangent. Ah.
Okay. All right, let's talk about some of these. Okay, we did sine 30, right? What's sine 30? 1/2. What's cosine pi over 6, or 5 pi over 6? That's still here. Cosine is the x value, so square root 3 over 2, and it's negative because it's in quadrant 2. Yes? What's cosine 45?
Got you. It's a square root 2 over 2.
Square root 2 over 2. Okay. Cosine 300. What's the reference angle? 60. So fold down your 60 finger. Which one's your 60 finger? This one. Okay. Cosine is the x or the y. The x or the y. The x. So it's 1/2. Okay. What quadrant is 300 in?
4.
4, so the x values stay positive. Does that make sense? Yes. Okay. Tangent pi over 4 is the middle finger. Fold it down. Tangent is x over, or y over x. So it's square root 2 over 2 over square root 2 over 2, which reduces to what? 1. Okay. Now, 180. What's the ones that are on the axes? I just think about the axis, okay? So 180 is -1, 0, right? Over here, -1, 0. What's the tangent if it's y over x? 0. It's not undefined. Does that make sense? Okay. So tangent is undefined here. It's 0 here. Okay. All right, what's cotangent? Do y'all remember from Algebra 2? What's cotangent?
It's the opposite.
Opposite of well, it's the flip of tangent. So instead of it being y over x, it is x over y. So fold your over 6 finger down, which is this one. Okay, it's x over y. So square root 3 over 2 over 1/2. Now, one of these is negative because we're in quadrant 4, right? 11 pi over 6 is in quadrant 4. Okay? The y is negative. So when you simplify this, it's negative square root 3.
How again?
Huh? You want me to simplify it for you? Square root 3 over 2 times negative 2 over 1. The 2's cancel. Yeah. Negative square root 3 over 1, or just square root 3. Negative square root 3. All right, cotangent of 225. What's the reference angle there?
That's
45. Okay.
1.
It's just 1, but what quadrant is this in?
-1.
Now think of
3.
it's in quadrant 3.
So it's
So-
negative. Positive.
It's positive because both of these are negative, so this one's going to be positive. Okay?
I like it.
Alright.
Okay.
Okay? All right, last thing. I'm not gonna give y'all, these are just more of them moving around the circle. I want to talk about this, so go down to the very bottom because we're on short. Otherwise, I would do the rest of them with you. Okay? We're on a short period. All right, pull your unit circle back out because I want you to do this one with your unit circle.
We're on a short period.
Yeah.
We have to take the ACT second.
We can schedule it.
There's a break. We still break.
We do?
No.
Yes.
Huh?
You're lying. That's Tuesday.
Okay, hold on just a minute and I'll talk about that. Okay.
We take.
All right. Hey, go to your unit circle.
I'm not doing it.
Everybody go to your unit circle. Brody, go to your unit circle. That response wasn't to me, right? That you're not going to do it? Okay. All right. I want you to put your finger on an angle that gives you a sine of 1/2. Did everybody hear what I say? Put your finger on an angle that gives you a sine of 1/2. What angle do you have your finger on? 30? Okay. Now, here's what I want to ask you. What happens if suddenly I ask you the sine of negative 30? Where's negative 30? Move your finger to negative 30.
330.
It's 330, right? What's the sign there? Negative 1/2. Do you see what happened? If I change the angle from being negative or from being positive to negative, what happens to the sign of my SIN sign?
It's negative.
It switches. Okay, what's cosecant? The flip of sine. So what's the flip of 1/2? 2. What do you think this is going to be? Apply what? Negative 2. Okay. So I wanted you to see the pattern on the unit circle because it's easier to see it there. Apply the pattern to one that's not on the unit circle. We don't have a 4/3 on our unit circle. Okay? Apply the pattern that we figured out here to these off the unit circle.
What's secant? It's the flip.
The flip of cosine.
So why did you just let them lie?
I don't know what you're talking about. Can I finish this and turn the recording off and then you can talk to me about that? Okay. All right. What's secant of negative t going to be? Negative 4/3. It's the flip of cosine. So what's cosine of t going to be? 3/4. And what's cosine of negative 3 or negative t? Negative 3/4. Okay, I just wanted you to see the pattern. Okay, because once you figure out the pattern, you can apply it to any of the situations. Okay. All right. I will fill out this part if you want to try these on your own, okay? The assignment for today is book problems, but they've already been uploaded to Canvas, and I have a sheet to give you to do it in the boxes, okay? All right, let me turn this off.